am recording now. Let's see. Glad to have you guys here. Okay, so guys, like I said, both today and Monday we're going to review for the final. I do have 3 different formula sheets that you have access to. The formula sheet for test 1, for test 2, and then the formula sheet for chapter 6. So in case you need that, those formula sheets will be there. And let's see. So guys, I had said originally today what we would do is we would go through the first like 15 questions. So I guess what we're going to do is I'm going to ask you guys which questions you want me to, we can talk about the first 15. So I just want to make sure that you guys feel good about the first 15. We'll do those today. Hello, hello. And then we'll do the next 15 on Monday. So what do you guys think? Should we try the first question here? What's the average rate of change? And you know what we're going to do? We're going to do it a little bit like this. So let me do this. Scroll down over here. Let me add a page here. There we go. And this is what we'll do, guys. Let's come back here. There we go. Let's do a little copy paste. And again, we'll see if we can answer these questions. I just need this part here. Copied it. Here we go. Paste it. Okay, so it says the following chart shows the living wage jobs in Rochester per 1,000 working adults over a 5-year period. What's the average rate of change in the number of living jobs from 2016 to 2018? Okay, so for this part, y'all, if I'm trying to find the average rate of change, aren't I just really finding the slope of the line? So I'm going to take 740 minus 665. 665. From 2016 to 2018, that's a 2-year period. So let me just grab my calculator here. So I'm going to say 740 minus 665 is 75. I'm going to divide that by 2. So I'm coming up with 37.5. So that's going to be my answer for part A. Am I good on how I did that part? Yeah, we're good? Okay, and then from 2018 to 2020, we're going to do the same thing, right? So now we're going to look at these 2 years. So we're going to take 785 minus 740, again, over a 2-year period. So 785 minus 740 should be 45 divided by 2. That should give me 22.5. Right, so those are the answers that I'm coming up with. So let me just check my answers to make sure we're good. 37.5 and 22.5. 37.5. And let's see, what's 22.5? Okay, let me submit it. Hey, we got it, right? Okay, so pretty straightforward type problem, right? You're just finding the slope of the line between those 2 points. Okay, let's take a look at number 2. And it says, based on the graph above, estimate to 1 decimal place the average rate of change from x equals 1 to x equals 4. So let me do this here, you guys. And I'm just going to do a little copy and paste again. So let me copy this guy here. Let's come back and let's paste it right there. And we're doing this from x equals 1 to x equals 4. Okay. So at x equals 1, if I were to kind of estimate what the y value would be here, I don't know. I'm going to say something like maybe like 1.2, something like that. You know, that's kind of what I'm estimating it to be, 1.2. At 4, I'm right here. So yeah, maybe something like 2.8. Okay. So again, what we're trying to do, y'all, we're trying to find the slope of that line, right? So we're just going to say, look, let's take 2.8 minus 1.2 over a distance from 4 minus 1. Okay. So 2.8 minus 1.2 should be something like 1.6 divided by 3. Okay. And again, if I take my calculator and say, what's 1.6, divide that by 3, I'm coming up with 0.533. So it told me to do it to one decimal place, I believe. So I'm going to say that roughly here, the slope is about 0.5, or the average rate of change is about 0.5. And so let's see, let me come back over here. So let's try a 0.5. And let's submit that. Hey, we're doing great so far, right? So far, am I making sense on how I'm doing at least the first two problems? Yeah, we're good. Okay, so let's try number 3. Okay, so now, Samathias earlier asked about the squeeze theorem. So we'll talk a little bit about the squeeze theorem in a minute with this problem. I don't know if Matthias is here with us today. Let's see. Is Matthias here? Oh, sorry. Steve, can you still hear? I got my mic on. Can you guys hear anything? Steve, no? Let's see. Steve, what about now? Steve? You're still off? Man. Noel. Noel, can you hear me, Noel? Let's see. John, I'm going to ask you to do me a favor. Can you log into Blackboard? I don't want to see if you can hear it. I got my mic on, so I'm not sure what's happening here. Yeah, you're good. Let me see. Make sure I got everything going on here. Let's see. Okay, so I don't know if let me see. I don't know if it's going to come up on your speaker or not. But I got the mic on. Okay, so John's in. Hello. Anything coming up? No, it's not. Okay. Let me see something. Huh? Hello. You can hear it? Okay, yeah. Yeah, I hear it there now. Do you hear it on your, can you hear it on this thing? It's a little delayed. Yeah. Steve, let me see. What would you say? Yeah. Yeah. Well, I'm giving some suggestions here. Okay, so it seems like the sound is there. So okay, I just wanted to make sure that you're good, Steve. Okay. Let's see. So let's come. I don't know. Uh-huh. Okay. If you're on your phone, you may need to enable your mic. Yeah. Okay, so now can hear me too. Okay, good. Just checking with you guys. Okie dokie. So look, let's talk a little bit about the squeeze theorem. So this is what the squeeze theorem says, y'all. It says, suppose the function h satisfies this inequality. So the squeeze theorem basically says that h is is between these two expressions, right? So yes, ma'am. I think so. Is it not letting you? Okay, let me. Okay, then give me 1 second, and I will fix that right now. So let me come back here. Let me come back over here. Let me click on the review. Let me go to this part here. Let me go to the settings. Okay. Let's see. Well, that's what. The number of versions question. Let's go like this. Let's go like, I don't know, 5. Number of tries. Let's go 8. Right. Save changes. Okay. So it should be there now. Okay, that was my bad. Like the assignments were already set up. I edited them, to pull the questions, but I guess I didn't edit the settings, and whoever had already done this had it like that. So, and I'll make sure, you know what? I'll make sure by the end of the day that the final is set up the same way, where you have, you know what I mean? You have a couple of tries per question, right? Because yeah. 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 So I want to make sure you guys are good. So yeah, thanks for letting me know. Okay, so it should be there now. But let's see. Let me come back to my problem. Okay. So guys, all it's saying is that this function h is going to be between these two expressions here, right? So it says we want to use the squeeze theorem to evaluate the limit as x approaches -1 of h of x. So look, the nice thing about this problem, they really walk us through it. It says first, let's evaluate 4x minus 2x squared minus 7 as x approaches -1. So remember what I'm going to do here, you guys. Everywhere I have an x, I'm going to plug in a -1. Okay? So let's see. 4 times -1 is a positive 4, minus 2 times -1 squared is still positive 1, minus 7. So this is going to give me 4 minus 2 minus 7. This is going to give me 4 minus 2 is 2 minus 7. This is going to give me -5. So right here, you guys, I'm going to put a -5. Okay. Now, we're going to do the same process all over again, but we're going to find this limit. Okay. So remember what I'm going to do. Everywhere I have an x, I'm going to plug in a -1. Okay. So let's see. -1 squared is 1. 2 times -1 is a minus 2 minus 4. So this is 1 minus 6. This is also -5, isn't it? Okay. So then, therefore, you guys, by the squeeze theorem, the limit as x approaches -1 of h of x would have to be what number? -5, right? So all it's saying is that that function h of x is always going to be between those two numbers. And so, or these two expressions, I'm sorry. And so we take the limit here. If that approaches -5 and this one approaches -5 and h is in the middle, h is going to have to be -5 as well, okay? Guys, when I remember when I took this when I was a student, they called it the sandwich theorem. The idea is the function is being sandwiched right in between those two expressions there.
So why is it like less than or equal to? Because if here less than you have to do the value below.
Yeah, but remember this is that's true. But remember we're taking the limit, right? So we're not actually we're saying what happens to the function as x gets closer and closer to -1. It gets closer and closer to what number? -5, right? Yeah, but it could. I guess it could have the equal to part. Yeah.
I think it should if you're gonna have this like
Yeah.
crazy less, right?
Yeah. So let's see. So we had a -5 here. We had a -5 here. And therefore, we're going to have a -5 right there. We're going to submit it. Oh, why not? Okay, so let's refresh it. Oh, man. Got it. Okay. Oh, man, I got to go through the whole thing again? Yeah. It's giving me new values, but we kind of get the idea, right? So let me go ahead and just skip over that. Sorry, guys. I hope nobody had hope you hadn't gotten too far. You know what I mean? Because it gets it did erase the answers or whatever. But anywho, okay, so now look, let's take a look at the next one here. And guys, I'll make sure, you know what? I'm going to do that real quick before we get there, right? Okay, so let's see. Let's see. Okay, so it looks like it's already set up. Number of times the test can be taken, 2. Number of tries on each question is 5. You know what I mean? So you get 5 before you get it wrong. But like you can try it 5 times. On the 5th time, I guess if you get it wrong, hey, you know, that was 5 times you tried to do the same problem, right? You probably don't know it at that point, but you're good there. Okay. All right. So let's see. Let's take a look at, this is question number 4. Okay. And then guys, like I said, on, yeah, go ahead. On Wednesday, I'm sorry, on next Monday, we'll go through the next 15, okay? So at least this way, you know, we're not doing a whole bunch of questions in one day. We're kind of spreading it out a little bit. But let's take a look here. It says, given that the limit as x approaches 4 of f of x is equal to 6, and the limit as x approaches 4 of g of x is equal to -3, let's find the limit as x approaches 4 of -6 f of x minus 7 g of x. All right, so again, first thing I'm going to do here, guys, is I'm going to put -6. Now, we know that the limit as x approaches 4 of f of x, this part is going to be equal to 6. Minus 7 times. Now, we know the limit as x approaches 4 of g of x is equal to -3. So right here, I'm just going to plug in a -3. And so now, what do we have? We have a -36 and a positive 21. And that's just going to leave me with a -15, right? So I should have a -15 as my answer. And so right here, you guys, I'm just going to enter that in, -15. There we go. Okay, so now let me go ahead and try the next part. Here we go. Okay, so again, I'm going to copy this one here, you guys. I'm going to copy this picture just so I can have a, you know, something kind of neat to look at. I'm doing this here. Okay, let me do a little copy there. And I'll tell you what, we're going to, yeah, we'll do it like that. That's good. Copy it. Okay, so I have this part here, and what we're trying to find is a couple of limits. Let me copy those limits here. Okay, so let's take a look here. What we're trying to find is we're trying to first find, hello, we're first trying to find the limit as x approaches 2. Does anybody remember what that means? When I have the 2 and I have the little negative sign? Uh-huh. Does anybody remember what that means? I'm coming in from the left side. Very good. So look, all that means, guys, is I'm approaching x approaches 2, but I'm approaching that from the left. So look, that just means I'm coming in from this way. So as I start to go up, what value am I getting really close to? I'm getting really close to 3, right? Okay. Now, when it says x approaches 2 and there's a positive sign, that says I'm coming in from the right side. And if I start going up, hey, you know what? I'm still getting close to 3. So then we can say, okay, do we now know what the limit as x approaches 2 is? Yeah, remember, the limit as x approaches 2, it's going to be whatever value you get from the left and whatever value you get from the right. And those two values need to be the same. And if they're not, then we would say the limit doesn't exist. So in this case, the limit would be equal to 3, right? Now, the next part says, what is f of 2? So guys, if I actually go on my graph at x equals 2 right here, if I were to go up, we'd pass right through that hollow point, right? So we're actually going to have to go down to what number? Yeah, and there we go, right? So that's what we mean by the limits, right? So that, remember, in order for a limit to exist, y'all, the limit from the left and the limit from the right have to exist, and they have to be the same number. Okay, so look here, my answers are 3, 3, and -4. So I'm going to scroll back over here. I'm going to go 3, 3, 3, and a -4. I'm going to submit it. Boom, there we go. Okay. So now that was number 5. Okay, let's take a look at number 6. Okay, so now, y'all, instead of me actually copying this one, I think I can probably just do it right here. But it says, look, the graph below is the function of f of x. Okay, and it says, determine which one of the following rules for continuity is evaluated at x equals 2. Okay, so let's take a look here. Is f of a defined? So if I were to go to 2, is the function defined at 2? No. So I'm going to say that's probably something that's violated, okay? And then, well, if this one is violated, then the limit can't be the same thing. So I'm going to say, oh, I guess it only gives me one option. Okay, so I'm going to say f of a is defined. That's the one that's violated, right? Because it's not there, okay? So if I hit submit, hey, we got it, right? Okay, and then I guess by default, if it's not defined, then the limit can't be equal to the other one. I'm curious. I'm gonna do this real quick. I'm gonna do a similar question. I'm curious if I do this one here, what it tells me. Now I guess it says that's not right. Okay. So what do I got to do? Similar question? Yeah. So then if I try this here, submit it. Yeah. Yeah. I guess that's what it is. I guess that's kind of funky though. I wish there was like a better way of wording it. Yes, sir. Yeah, I know. I thought I had it like that and I didn't, so I just fixed it so that it does. The only bad part, it wiped out all the questions we had already done. Okay, okay, yeah, yeah. We were doing that right now. Jennifer brought it up. We were on the third question. So I reset the settings so that it lets you, get multiple attempts or whatever. Uh, and then when I went back to it, it wiped out my answers for 1 and 2. So yeah, sorry about that, man. I thought it was there. Okay, so let's take a look, guys. I bet you we can do this one pretty straightforward, right? And what I'm hoping here, Gail, as we're going through these problems, I'm hoping you're kind of getting a feeling of, like, you know what? I'm going to be able to do okay on this test as we're going through these problems, okay? Because you can see so far the questions we've been going over. Again, y'all, I pulled these questions directly from your test 1, directly from your test 2, and then I pulled a handful of problems from chapter 6. There's not a lot of them there, right? So the nice thing is every one of these questions, we've already actually seen them because we either did it on test 1 or test 2 with just a few exceptions from the stuff from chapter 6, which, if you've done the homework, then you're good there too. Okay, so look, let's find f prime of x. So f prime of x, the derivative of 5 is 0, so that's going to go away. The derivative of 2x should just be at 2. And the derivative of a minus 4x squared, negative 8x, right? Okay, so now we're going to find f prime at 2. So I should just be coming up with a negative 14, right? We should just be getting a negative 14. So let's try that here. So right here, you guys, I'm coming up with a minus 14. There we go. Okay. We're doing good so far. So hey, look, we're like halfway done. We're already on question number 8. So okay, good. Just making sure everybody's still good here. Come back this way. Here we go. So let me copy question number 8 here, you guys, and then we will figure this bit out. Okay. Okay. Okay, so it says, find the indicated derivatives using the following information. Okay, so the first part here is asking us to find the product of the derivative at 2. Okay, so remember, y'all, when we're going to use the product rule, we usually go f of x and g of x. When we're trying to take the derivative of this one you can be a little bit more flexible. You're going to take the derivative of one with the other function, and then the derivative of the other one with the other function. I don't know if that makes sense, but what I'm going to do here, I'm going to go like f prime of x times g of x plus f of x times g prime of x. So if you notice, we took the derivative of one of them, and then with the second function, and then the derivative of this one with that one by itself, right? Now, which one do you put first, second? It doesn't matter. You know why? Because we're adding, right? And when you add, it doesn't matter which number comes second. Does that make sense? Okay, so now let's take a look. We're doing this, you guys, at 2, right? So we're going to go f prime of 2 times g of 2 plus f of 2 times g prime of 2. Okay? So I'm just going to start plugging my numbers in. F prime at 2. F prime at 2 is 5. Okay? Times g of 2. G of 2, y'all, happens to be 4. Okay? Plus f of 2. Well, f of 2 is a negative 4 times g prime of 2, which is a positive 3. So let's take a look here. So I'm coming up with 20 plus negative 12. That should just be equal to 8. So for my first box, I'm going to have an 8. Okay. Now, let's do the second part. Let's do the f divided by g prime of 2. Okay. F divided by g prime at 2. Okay, so y'all, remember, I'm going to call this the top function and the bottom function, right? So remember, my product rule says the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom square. Okay. Okay, so now, look, I'm going to kind of scroll back here. Actually, you know what? Let me try and see if I can fill it in right here. Okay, there we go. So just copied it again. Now, I want you to notice here, you guys, what's my bottom function, what's my top function? My bottom function is g, okay? So the way I'm going to do this now, I'm going to just go g of 2. The top function is f, so f prime at 2 minus the top function is f 2 times the bottom function derivative, g prime at 2, all divided by the bottom function squared. So divided by g of 2, all of that being squared. Okay. And now, guys, it's just plug and chug, right? So look, g of 2. G of 2 happens to be the number 4 times f prime at 2. F prime at 2 happens to be the number 5 minus f of 2. Well, f of 2 is a negative 4 times g prime of 2. G prime of 2 is 3. Okay. All of this is being divided by g of 2 being squared. So 4 being squared. Okay. So now I'm just going to go one piece at a time. That's a 20. Let's see, that's going to be a negative 12, but with another minus makes it plus, so plus 12. All over 4 squared is 16. So 20 and 12 gives me 32. Divided by 16 is just going to leave me with a 2. Okay. So for the bottom one, we got a 2, and for the top one, we came up with an 8. Okay. So look, y'all, I'm going to just scroll back over here, and I'm going to put an 8 and a 2. So 8 for there, 2 for there, submitted. Hey, and we're doing okay, right? Guys, the one thing I really want to kind of emphasize, and I'm kind of seeing this now as I'm going through the problems myself, is remember, there really is no time limit on the test, right? There's no time limit on it. And you know what? I'm gonna double check that in a second too, just to make sure that there is no time limit. So let me, before I go anywhere else, let me make sure that that's still the case. that there is no time limit. Let's see, what was the time limits right here? Okay, so no time limit. Yeah, there's no time limit on here, guys. Okay, so we're good. Okay, so the one thing I would really encourage you is, since there is no time limit on the test, go really slow, right? Just take your time with it. I know, everybody has other things outside of school, and I don't want to try to minimize that. But what I would definitely say is, whenever you're going to do this, try to do it in an environment where you don't have a lot of distractions, right? Where you don't have like, oh, I got to go to work in an hour, and I'm going to try to do, some of the stuff. And obviously, since there's no time left, you can always come back and work on it. But really, I would say, try to sit down and get through your questions, right? So that you can get them done. You know what I mean? I think less distractions obviously, I think is always a better way to go. But that's just, I don't think I'm telling you anything that you don't already know. All right, so look, let's take a look here, y'all, at number 9. Okay, so let me copy this guy here. Boom. Okay, and then we're going to paste it over here. Okay, so it says, look, find y prime, and then find the slope of the tangent line at 3, 676. Round the slope and the y-intercept to 3 decimal places. Okay, so let's see if we can find y prime. All right, so you guys, in case you didn't realize, I am going to have to use the chain rule here. Okay. So y prime, remember the way we're going to do the chain rule. We're going to say, we're going to bring this 2 down to the front, and then I'm going to leave everything I have inside there, x squared plus 5x plus 2. And then I have to subtract 1 from that exponent. Well, if it was 2 and we subtract 1, we still got 1, right? So it's there. And then we now have to take the derivative of the inside. Okay. So let's see. What is the derivative of x squared plus 5x plus 2? Anyone know? 2x plus 5? Yeah, right? 2x plus 5, right? Okay, so we're good there. Now, guys, I'm pretty sure that my open math is pretty flexible with you guys, right? And I don't think you need to go through a whole lot of business. And you can probably just leave it like that, right? Okay, so that's the nice thing, right? I mean, the algebra part of it, they're not drilling this too hard on it. They're saying, we can leave it there. Now, the second thing is, yeah, right? So the next thing is we want to find the tangent line. So guys, just a reminder, remember, when we find the derivative is telling me this is the function that's going to give me the slope at a given point, right? So if I want to find the slope at when x is equal to 3, what we're now going to do, y'all, is we're going to come back to our slope or our derivative function, and everywhere we have an x, we're going to plug in a 3. Okay? So notice, all I did here, you guys, is everywhere there was an x, I replaced it with a 3. Okay? There we go. Okay, so let's go slowly. Y prime at 3 is equal to 2. Let's see, 3 squared is 9. 5 times 3 is 15, plus 2. 2 times 3 is 6, plus 5. Okay. Let's see, 9 plus 15 is 24, plus 2 is 26. 6 and 5 is 11. Okay. So guys, I'm just going to grab my calculator here. 2 times 26 times 11. And I'm coming up with 572. This right here, you guys, is my m, right? Am I good on that part so far? Okay, so now, remember, the next thing I'm going to do here, you guys, is we're still trying to find the equation of the tangent line. So the first thing we have to do is find the m. I'm going to give you a hint. That number right there, you guys, is going to be the number that I'm going to write right in there. Because remember, I'm writing my equation in the form y equals mx plus b, and we already have the m value, right? Okay, so since the point that we were given was 3 comma 676, what we're going to do now is we're going to go ahead and write out that equation. Okay. So remember, the equation, you guys, is y minus y1 equals mx minus x, right? This is the equation that we use. So remember, this is my x1, and that is my y1 right there. Okay. So look, now I'm just going to plug in y minus 676 equals m, which we just found to be 572, x minus my x1, which is a 3. So y minus 676, and I'm just multiplying here. So 572x minus whatever 572 times 3 is, 1716. Okay. And then I'm just going to add 676 on both sides. Let's see. So negative answer plus 676. Negative 1040. So, okay, I came up with y equals 572x minus 1040. So guys, I want to show you something here. When I come back to this part right here, look at the way they have my answer. They have y equals what x? Oh, the what is the number in front of my x. So that's a 572 plus, look at the number that I have at the end. I have a negative 1040. So I'm just going to write a minus 1040 right there. Okay, so let's go ahead and enter that stuff in. Come back this way. Okay, so what did I get for the first part? 2 times x squared plus 5x plus 2 times 2x plus 5. Okay, so 2 x squared plus 5x plus 2, and then times a 2x plus 5. And then here, this was a, what, 572? That was a negative 1040. And I'm going to go ahead and hit submit. There we go. All right. So let me go ahead and jump over to number 10, you guys. Okay, so it says use implicit differentiation to find dy dx without solving for y. Okay. So again, we're going to see we can do the same kind of, this is a very similar problem to the one we just did, and that first we're going to find the derivative, and then we're going to find the equation of the tangent line. Okay. So let's come here, and we're going to go slowly. Okay, so first thing we're going to do here, y'all, is we're going to do some implicit differentiation. Okay, so we first need to find the derivative of this piece here. Okay, so remember, guys, we're going to use the chain rule, right? First thing that's going to come down is the 4, right? Then we're going to have x plus y. We have to go one less power. So what power would I have now? 3. Okay, times. Now we got to take the derivative of the inside. What's the derivative of x? 1. What's the derivative of y? Yeah, right, because remember, so here, guys, this is when I'm having to use that implicit differentiation, right? I'm finding my derivative. Again, remember, you can call it dy dx, you can call it y prime. It's the same thing, right? Okay. Now, equals. So we're going to work with the right side. Okay, so guys, I'm going to do the product rule here. So remember, when I'm doing the product rule, I'm going to take the derivative of one piece with the other one, and then the derivative of the second piece with the first one. Which one do you want to take the derivative of first, second? It doesn't really matter because they're going to be added. Okay. So look, suppose I decide to take the derivative of x to the third. Everybody agreed the derivative of x to the third is a 3x squared? Okay, times a y to the third. I don't take the derivative of the second one. Now we do the first one by itself, which is x to the third. And now we have to take the derivative of y to the third. So guys, remember the derivative of y to the third is going to be 3y squared, and then my dy dx, okay? Because I'm taking the derivative of y, okay? All right, before I go on, are we okay in how we got to what we used? Okay, so guys, look, we're gonna go really slowly here, okay? We're gonna distribute this guy here times that. So that's just gonna be 4xy to the third. We're gonna do the same thing times that. So 4x plus y to the third with my dy dx, okay? Equals. Now this is a 3x squared y to the third. This part here, you guys, I'm going to write it as a 3x to the third y squared and a dy dx. Okay. Now, the next part, since we're trying to solve for dy dx, we want to get this piece here and this piece here on the same side, okay? And we want to move the other ones to the other side. So I'll tell you what I'm going to do. I'm going to leave this guy alone. So I'm going to leave this 4x plus y to the third with a dy dx right there, okay? Now, I'm going to bring this guy over to the other side. When I cross the equal sign, what's going to happen to the sign here? It's going to become negative. So look, negative 3x to the third y squared with a dy dx, right? Equals, okay? Now, I'm going to leave this guy alone. So I'm going to leave that 3x squared y to the third by itself, but I want to bring this one over here with it. So when I cross the equal sign, what's going to happen to that 4? Yeah, so we're going to have a minus 4x plus y to the third. And does it look messy? Yeah, it looks really messy, right? But that's okay, because remember, my open math is pretty forgiving about how I enter my answers in. They're not going to be so particular about combining terms and all that kind of good stuff, right? Yeah, if we did, because again, remember these problems, John, I pulled them directly from your test 1 and test 2.
No, I know what the answer is.
But remember, I haven't even solved for dy dx yet, right? So that's what I'm trying to do. So look, guys, I'm going to factor out this dy dx. I'm going to put them over here in the front. When I factor that out, I still have a 4x plus y to the third minus a 3x to the third y squared equals 3x squared y to the third minus 4x plus y all raised to the third. Okay, finally, my last step. Let's get rid of this guy here. So let's divide 4x plus y to the third minus 3x to the third y squared on both sides. Okay. So that and that will go away. This right here, my friends, is going to be my dy dx. Okay. So look, really, before I go on to anything else, y'all, I'm going to enter that part in as the first part of my answer. Okay. So let me come back over here and let me enter this part in. I'm going to see if I can do, here we go. Okay, so first thing I want a fraction. So 3x squared y to the third minus 4 parentheses x plus y. And on the outside of that, that's being raised to the third. Okay. And on the bottom, I have a 4, parentheses again, x plus y. Outside of that is also a third, a minus 3x to the third, and a y squared. Okay, so I got that part done. We'll come back and we'll do the next part in a second, okay? Man, that AC is going crazy, isn't it? Pretty loud. Yeah, bless you. Yeah, same here, same here. Okay, so guys, look, now the second part says we want to find the slope and the y-intercept of the tangent line. And the point they give me is a 0.33. Okay, so all we're going to do here, y'all, for my dy dx, is we're going to evaluate this at 3 and 3, right? So what does that mean? That means everywhere I have an x, I'm going to plug in a 3. Everywhere I have a y, I'm also going to plug in a 3. Okay. So if I were you, this is what I would do. I would probably go with, let me open up a big set of parentheses. Okay, and in my second set of parentheses, I'm going to type in 3 times 3 squared times 3 to the third, okay, minus 4 times 3 plus 3, I already know is 6 to the third. Okay, so that's my top part. Divided by, I'm going to do another set of parentheses. Let's see, 4 times, let's see, 3 plus 3 is 6 to the third, minus, and then I'm probably going to do parentheses again, 3 times 3 to the third, times 3 squared. Let's see if I do that, if that works. Hit enter. Anybody get a -1? Oh, man, all that mess for a -1. Okay. Yeah. Okay, so look, guys, we got a -1. Remember what we just found here? What we just found, you guys, was the slope at the 0.33. Okay, that's what we just did. We just found the slope of the line at the 0.33. So now, the second part, this part's going to be the easiest, breeziest cover girl problem we've had now. Check this out. Look at the numbers I'm going to plug in. I'm going to plug in 3's and -1. So look, y minus 3 equals -1, x minus 3. So this is y minus 3 equals a -x and a +3. So when I add 3 on both sides, I am coming up with a y equals a -1x plus 6. Okay? That second part was obviously a whole lot easier than doing the first part, right? The implicit differentiation, it can be messy. There's no doubt about it. It can definitely be messy. Usually the second part, you guys, where you're trying to find the equation of the line, I always say that's a pretty straightforward type process, just because in so many classes that we've taken, we've figured out how to find the equation of the line. When you have the slope and you got the point, it's easy to find the equation of the line. So guys, I'm going to go ahead and enter that in now. So y equals a -1 x and then a +6. Okay, let's bring this up here. Let's submit it. Let's see what happens. Oh my goodness. We done got it, right? So, are we good? Matias, am I doing okay here? Yeah? Are you sure? Okay, just checking with you, man. Just checking. Okay, so look, guys, let's do 11. We'll go through the first 15 today, you guys, and then we'll do the next ones on Monday. Okay, so look, let me do a little copy and paste here. And let's see. So here we go. Come back over here. Okay, question. Does anybody remember how to do logarithmic differentiation? If you don't remember, that's okay too, guys. Anybody remember off the top of your head? Not really? Okay, so look, this is what I would do again. If I was sitting where you're sitting, this is what I would do. So look, y'all, in the folder where I put the final exam info, I did give you guys formula sheets, right? The formula sheet for test 1, for test 2, and test 3. So in the formula sheet for test 1, and I'm just going to open this up here, and I'm going to scroll through until I find logarithmic differentiation, okay? So look, we're going to scroll down. This is all limit stuff. This is tangent. That's chain rule. So log differentiation. Here we go. So look, this is what I'm going to do now. We're going to do a little copy and paste. Okay? And again, y'all, what I'm trying to do is kind of give you the approach that if when you're taking your test or you're going through the review problems on your own, if you're like, how do I do this? It's important that you know how to use the resources that you have, right? So it's not so important, guys, that you remember everything by heart. I think it's important that you know how to find the solution. You know what I mean? Okay, so let's take a look here. It says, look, to differentiate y equals h of x using logarithmic differentiation, we're going to take the natural logarithm on both sides. Okay, so the first thing we're going to do here, you guys, before we actually take the logarithm on both sides, we're going to write out our problem like this. Y equals 8x minus 2 to the fourth times 2x squared plus 8, all being squared. Okay, now we're going to take the natural log on both sides. So I'm going to have the natural log of y equals the natural log of 8x minus 2 to the fourth times 2x squared plus 8 all squared. Okay, now it says use the properties of logarithms to expand this piece as much as we can. So we want to try to expand that part there. So look, I'm going to leave this alone. Natural log of y equals the natural log of, since we have a product here, one of the properties of logarithm says you can break this up into the sum of two different logarithms. So we can write this as 8x minus 2 to the fourth plus the natural log of 2x squared plus 8 all squared. Okay. We're going to use one more log property, you guys. So we're going to go natural log of y equals. One of the other properties says when you have exponents, those exponents can move down to the front. Okay. All right. Now it says differentiate both sides of the equation. On the left, we're going to have 1 over y dy dx. Okay. So when I take the derivative of y, this is going to leave me with a 1 over y and a dy dx. Okay, so now, in case you forgot the derivative of the natural log, let me see if I can come back over here. Do I have the derivative of the natural log? I thought I had it right here. Here we go. So look, the derivative of the natural log, let me just kind of zoom in real quick, you guys. The derivative of the natural log is 1 over your function times the derivative of the function itself, okay? So let me explain what I mean by that. When I'm taking the derivative of, say, this piece here, I'm going to leave the 4 alone. It's going to be 1 over 8x minus 2 times the derivative of 8x minus 2, okay? So what's the derivative of 8x minus 2? 8, okay? There's all being multiplied. Plus 2, okay? 1 over 2x squared plus 8. What's the derivative of 2x squared plus 8? 4x. Okay. Now, guys, I'm not going to do a lot of simplifying here. Okay, I'm really not going to do a lot of simplifying. I'm just going to do some minor simplifying. When I multiply on the top, that's a 32, 8x minus 2. Plus, when I simplify this on the top, that should give us an 8x, 2x squared plus 8, right? Last thing I want to do here, you guys, I'm going to multiply everything here by the letter y. Okay. The reason I want to do that, I want to get rid of that y down there. So that's going to give me dy dx equals 32, 8x minus 2, plus 8x, 2x squared plus 8. Okay. Now, times y. But I want you to think about what y was equal to from the very beginning. Y was equal to the original function, right? So look, I'm just going to write an 8x minus 2 to the fourth and a 2x squared plus 8 squared. So right here, I'm going to put an 8x minus 2 to the fourth and then a 2x squared plus 8 all squared. And I'm not going to, I'm sorry, go ahead. Who? Oh, me? Why? Oh, well, I'll tell you what. So I look at it right here, right? Aren't those that 8x minus 2 and the 2x plus 8, aren't those the same numbers that I have here? So all I had to memorize was the 4 and the 2. You see what I'm saying? Yeah, no, but I appreciate the compliment anyway. A lot of times I feel like when I'm doing these problems, guys, and I don't remember if it's happened to us in our class, but I know it's happened in a bunch of my classes. When I make the little videos for you guys and I do it on my iPad and I have to go back and forth like between maybe not, I'm not so sure if I do it for this class, but I know like for my other classes where we use my math, and I have to go back between me where I'm working out the problem, my math lab, and my calculator. I forget the numbers, and I'm like, man, is my memory already kind of, I'm like, I'm 48. Is this happening already? Like, I hope not. I don't even think you need to worry about that, Don. I think we'd probably be okay just entering it in like this. And so look, I'm going to try that because again, my math or my open math is pretty forgiving on a lot of this stuff here. So this is what we're going to do. We're going to see, let's see. Okay, I guess we're just writing in the actual answer. So I'm going to go parentheses, all this kind of stuff here. 32 over 8x plus 2. Okay, so let's try this. Do a fraction. Actually, before I do a fraction, I'm going to do parentheses. I'll do a fraction. 32 over 8x minus 2. And then we had what? Plus 8x plus, let's do a fraction again, 8x over 2x squared plus 8. This plus 8. There we go. Okay. And then all that was being multiplied by the original problem, right? Oops. Yeah. So let's see. Let's do it this way. 8x minus 2 to the fourth times 2x squared plus 8. There we go. Oh yeah, squared, sorry. Thank you. Submit it. Boom. Same thing, right? I just wrote mine the other way. But yeah, same thing. So yeah, so again, I guess the nice part, implicit differentiation, guys, and log differentiation definitely take time to do, right? So, but the nice thing about it is you're not having to do so much simplifying. And I want to say that when we did these problems in class, like I was really trying to simplify a whole lot, and we don't really need to do any of that stuff, right? It's just like take the derivative and then you're done. Don't worry about, oh, should I try to combine like terms here? Nothing like that when you get to these kind of problems. Okay? So look, let's take a look at question number 12. All righty. So this one looks a little bit more straightforward. So let me copy this guy here and let us paste it right there. Okay, find the first derivative of y equals 3 sine of negative 5x to the third plus 20. Okay, so we're going to find our y prime. Okay, so it's still going to be 3. What's the derivative of a sine? Cosine, right? Cosine of negative 5x to the third plus 20. Now, guys, remember, I still need to take the derivative of my angle. So what is the derivative of a negative 5x to the third?
Negative 15x squared.
Negative 15x squared. So, guys, again, I'm not going to simplify a whole lot here other than probably put those two guys together. The 3 and the negative 15 is going to leave me with a negative 45 x squared cosine of negative 5x to the third plus 20. But I would probably venture to guess that even my open math would probably be okay with you just entering that as you see it right there. You know what I mean? I don't think they're going to be that picky. Like, I would probably just put those together just because, I don't know, I'm a math teacher and that's what I do, right? But you know what? I'm actually going to enter it in just like this as I see it. And I'm pretty confident it's going to say, hey, you're good. So look, I'm going to write it as we see it. So we had a 3, we had a cosine of a negative 5x to the third plus 20. And then on the outside, we had a negative 15x squared. Okay, so I'm going to enter that in like that. I'm going to submit it. And it even let me put it that way. And what did it ask for? It asked for the, what was it looking for? It was looking for that negative 45, right? But you see how I didn't even simplify that part and it still took it, right? So again, my open math, I think, is very forgiving when it comes to that kind of stuff, right? Now, obviously, guys, and one thing, if I would put it this way, if you feel less confident in your algebra skills, don't simplify. Because suppose when you're going to put those numbers together, you say, oh, 3 and a negative 15, you write like a minus 12 because you were adding or subtracting instead of multiplying, Then all of a sudden you've got the problem wrong, right? But hey, if you don't want to simplify, don't simplify. It's pretty forgiving when it comes to that. All right, so look, let me do this next one here. Again, I'm going to copy and paste it. Okay, so let's go like this. Copy, boom, come down here, paste, there it is. Okay, so it says the area of a healing wound is given by A equals pi r squared. The radius is decreasing at a rate of 2 millimeters per day at the moment when r equals 45. How fast is the area decreasing? Okay, first thing I'm going to do here, you guys, it's telling me that the radius is decreasing at a rate of 2 millimeters per day. So that means that my dr dt is a negative 2 millimeters per day, right? Because that's the rate at which the radius is decreasing. Okay, we're trying to find how is the area decreasing. So look, there's the formula for the area of a circle. We're going to find the derivative of the area. So dA dt is going to be equal to 2 pi r. Then I still have to take the derivative of r. Well, that's what we call our dr dt, right? Okay. So look, y'all, I'm right here. I'm just going to go like this. dA dt equals 2 pi r. They gave me a value of r. They already told us that r was 45, and we knew that our dr dt happened to be a negative 2. Okay. So dA dt, let's see, 2 times 45 is 90. 90 times 2 is a negative 180 with a pi. Okay. So I'm coming up with a negative 180 at a pi. So guys, the first thing I'm going to do here when I come back to my problem is, I don't know if my open math wants me to put the pi in, or do they want me to, do the approximation? Okay, well, let's do it like that first. Let me try this. I just want to see what the answer would be if I did it with a pi. If I did it with a pi, I'm looking at like 565 point change, right? If let's see, so we came up with a 180 and a pi, right? Do I have a, yes, we do. We got a pi symbol right there. Now, this is millimeters per day. Now, guys, I want you to notice something. The answer that we came up with when we did it was actually a negative 180, right? Okay. Now, the question says, how fast is the area of what? Decreasing, right? Since it says it's decreasing, it's understood that it's going to be negative, right? When I have this right here, this tells me that the area is decreasing. How do I know it's decreasing? Because it's negative, right? But because the question is worded in a sense that says, how fast is it decreasing? I don't need to put the negative in, because if I put the negative in, that would mean it's decreasing at a negative rate. Well, when something is decreasing at a negative rate, it's actually increasing, right? And that's not what's happening. So millimeters per day. Oh no, what did I do? Okay, my millimeters per day was off. Oh yeah, square millimeters per day. That's right, because it is area, right? My bad. So let's try that part. Boom, there we go. So 180 square millimeters per day. That's right, because it's area, right? All right. So look, let's try number 14. Okay, so let's see if we can figure this thing out here. 14. Let me copy this here. Excuse me. Okay, so it says, consider the function f of x equals 3 minus 5x squared over the interval from -4 and 2. It's asking me, what is the absolute maximum value and what's the absolute minimum value? Guys, when we're doing absolute maximums and minimums over a closed interval, there's a couple things we want to do. The first thing we want to do, we want to find the derivative. Okay, so when we find the derivative of a 3 minus 5x squared, everybody agree that's going to be a negative 10x? Okay, what we're going to do now is we're going to find what we call, the critical values or critical points, right? The way we do that, you guys, is we take the derivative, well, we set it equal to 0, okay? So when I set it equal to 0, everybody agree I come up with x equals 0? Okay, now that we've done that, what we're going to do, step number 3, we're going to find the function evaluated at the endpoints, as well as the critical values that happen to fall within those endpoints. In this case, you guys, my critical value is 0, and 0 is a number between -4 and 2. So I'm going to evaluate it because of that, because my critical value happens to fall within those endpoints. I want to make sure that I evaluate it at that critical value as well. Now I'm going to make this up, guys. Suppose the value that I would have gotten here, I'm just going to make this up. Suppose the value I would have gotten would have been x equals 3. And I would say, well, you know what? 3 is not in that interval. I wouldn't use 3. Okay, I'm only going to use the numbers, the critical values that happen to fall within my interval here. Does that make sense? Matthias, am I doing okay? Yeah, we're good? Okay, so guys, when I say by the endpoints, what we're going to do now is we're going to find f of -4, we're going to find f of 2, and we're going to find f of 0. Okay. So let's see, 3 minus 5 times -4 squared. This is 3 times 5, 16. So let me see. 3, 3 minus 80, which would be -77. There you go. -77. Okay. Now we're going to do the same thing at 2. 17? Negative? Okay. And then at 0. Anybody know? 3. Okay. So look what we're looking for, guys. We're looking for the absolute maximum and the absolute minimum. So remember, absolute maximum means what was the biggest value that we got? Wasn't the biggest value we got, wasn't that 3? That was the highest point, right? So the highest point was 3. We got 3 when x was what number? Very good. Okay. Now, what was the lowest point in the graph? Negative 77. Excellent. And that happened when we plugged in x equals? There you go. And that's how I find absolute maximums and absolute minimums. Does that make more sense? Are we good with that? Cool. Okay, so look, you guys, I'm going to plug in those numbers. We're going to check our answer just to make sure that we're doing good here. So look, we got a 3 and a 0. And then we had a negative 77. And that happened at, what was it, negative 4? Is that right? Yeah, negative 4. Okay. And we're going to go, let's submit it. And, man, check us out. I'm making 100 on this review. Right? Okay. So look, let's copy 15, you guys. And again, we'll do this problem here. And then on Monday, we'll pick up with 16 through 30. And again, this way, we do half of it today, half of it on Monday. And again, I'm hoping that as we go through these guys, these problems are making sense. I'm really hoping that you're getting a feeling of like, okay, this is doable. You know what I mean? Like, I don't want you like, oh man, I remember this. As we're going through it, and I know, guys, especially the log differentiation and the implicit differentiation, I think those are probably the most challenging problems that we've seen, at least in the first 15. But I'm hoping that this stuff makes sense here. Okay, so I'll tell you what I really like about this problem number 15 is that it's very, they give me kind of like a lot of instructions on the first part. So it says, look, consider the function f of x equals 2 minus 3x squared over the interval from negative 3 to 3. Find the average or the mean slope of the function. In other words, look what they're telling me to do. Tell me to find f of 3, tell me to find f of negative 3, subtract them over 3 minus negative 3. Let's do that. So f of 3, 2 minus 3 squared let's see, 3 squared is 9 times 3 is 27, so that's a negative 25. Okay. F of negative 3. 2 minus negative 3 squared. Okay. Let's see. Negative 3 squared gives me a positive 9. This is still 2 minus 27. That's still a negative 25, right? Okay, so look, for the top part here, you guys, we're going to plug in this number, negative 25, minus this number here, a negative 25. 3 minus negative 3 becomes 3 plus 3, which is 6. Minus and minus become plus. Anybody know what's a negative 25 and a positive 25? Cancels out to 0. So 0 divided by 6 is still 0, right? Okay, so look, for the first part, guys, we came up with a 0. Okay, now, the second part says, by the mean value theorem, we know that there exists a C in that open interval so that f prime at C is equal to that mean slope. Okay, so look what they're telling me. We're going to find the derivative. So look, y'all, for part B, I'm going to find the derivative. I want to find f prime of x. If my f of x is equal to 2 minus 3x squared, does anybody know what f prime of x should be? Negative 6x. Okay. So part B, guy says now what we're going to do, we're going to take that derivative and we're going to set it equal to the answer that we came up with over here. We'll look at the answer we came up with. In this case, we came up with the answer being 0. So we're going to set it equal to 0. Okay. So when I divide both sides by a negative 6, everybody agree I'm coming up with an x equals 0? That's all we're trying to find right here. Whatever answer we came up with, we take our derivative, y'all, we take that derivative and we set it equal to the answer that we came up with in the first part. And then what we do after that is we take that derivative, set it equal to it, and solve for x. So in this case, for both of them, I came up with 0. So look, I'm going to put a 0 here, and a 0 there. I'm going to submit it, and there we go, we got it. I'm going to check something, guys. I'm curious to see if, okay, so look, I want to do the same problem that we did right now. I want to do this one here, just because I want to show you guys something, okay? So I know we just did 15. I just did it to where it gave me a similar question. But I want to do a similar one, y'all, because sometimes when we come up with zeros, we always think like, oh, should I let my answer be equal to 0? And that's not always the case. Okay. That's what we got the first time we did it. All right, so look, I'm going to go through the process again. I just want to do a similar problem. Look what we have here. We have f of x equals 3 minus 3x squared. It's just a different, right, but, well, is it the same function though? Now, this was a 2 minus 3x squared, right? But I want to show you this one because my answer here is probably not going to be equal to 0, okay? So look, you guys, we're going to find f of 3. So 3 minus 3 squared. This is 3. 3 squared is 9. 9 times 3 is 27. That's still a negative 25, okay? But look, let's now find f of negative 5. Okay. What's negative 5 when you square it? Anybody know? Uh-huh. 5. Okay, so 3 minus 75. What's 3 minus 75? Negative 72. Okay, so look, you guys, look at what the directions are telling me to do. They're telling me, let's find f of 3, let's find f of negative 5, and let's subtract it. So we're going to go negative 25 minus a negative 72 over 3 minus negative 5 becomes 3 plus 5, which is an 8. So look, this becomes positive. So what's 72 minus 25? 47. So I'm coming up with a 47 over 8. Okay? That's what I'm going to set equal to here, you guys. That's going to be equal to 47 over 8 because that's the answer that I came up with, right? Okay, so now for the second part, what we're going to do, we're going to take the derivative of our function. So my original function was f of x was equal to 3 minus 3x squared, right? What I need to do is I need to find f prime of x. Okay. F prime of x, you guys, wouldn't that be a negative 6x? Okay, we're going to set that value here equal to what we came up with in our first part. Okay. So, you guys, could we do this? Could we multiply everything by a negative 1/6? Because those 6's will cancel. A negative and a negative gives me a positive. 47 times negative 1 is a negative 47. Anybody know what's 8 times 6? And that's my answer. So guys, the reason why I wanted to do this, like a different version of the problem, when it's 0, it's kind of boring. You know what I mean? Because whatever we got for our answer here, like we came up with 0 for the first part. Okay, look, we set it equal to 0. We got 0 again. You see what I'm saying? But what happens when that number is not 0? It doesn't, you know what I'm saying? It's not so straightforward. You see the point that I was trying to make? So I wanted to make sure that, you know, that when you're doing your test, you don't say, oh, look, I remember this problem, it's 0 and 0. You know what I'm saying? Like I didn't want you to have that experience, right? So look, I'm coming up with 47 over 8 and a negative 47 over 8. So right here, fraction 47 over 8, and right here, fraction negative 47 over, what did we say, 48? Okay, submit it. Oh no, what did I do wrong? Oh, you know what? I thought I put one of them wrong, didn't I? It says that 47 over 8. What again now? Oh, you know what? Why is that not right? It says this is 1 cube. F of,
All we have to do is
let me see, did I make a mistake somewhere? F of 3 was negative 25 minus 22. Let me see. That's negative 20. Oh, you know why? I know why. This is not a negative 25. This is 3 minus 27 is a negative 24. Hello. J to the hello. Okay, so now let's see. And that is 72. Okay, so that was my bad right there, guys. Sorry about that. Let's see. Negative 24 plus 72, 48. 48 over 8, which is 6. Okay. So that's supposed to be equal to 6. Okay, so my bad. And then, let's see. Let me fix this part again. Okay. Okay, so now y'all, sorry about that. We're going to go negative 6x equals 6. So x would just be negative 1, right? Okay, so 6 and a negative 1. Okay, that's where I made my bad. Sorry about that. All right, so let's change this guy here to a 6. Let's change this one here to a -1. And let's submit it. Much better. There we go. Wow. So there we go. Much better, guys. Okay, so again, that was why I didn't want to just do it the one where it had the zeros, guys, because when it has the zeros, it can be misleading. You know, so my point, like it's like, oh, look, the answer is 0, and that's not always the case, right? Yeah. So anyway, just kind of wanted to go through that stuff, guys. Like I said, on Monday, we will pick up with 16 through 30. Okay, so look, it took us about, I don't know, a little bit over an hour and 20 minutes or so to go through the first 15. We'll take the rest, you know, another hour or so, hour and a half, whatever it takes us on Monday to go through the next 15. Guys, just a friendly reminder, the test will open up on Monday. So again, if I click on this deal right here on the test, it says, look, it's not available yet. It'll be available Monday at, you know, the 9th at 2:50, and it's due by Thursday by 8 o'clock. Okay. So again, just to give you a heads up, you know, it's there. Again, guys, you know, on, like I said, Monday, we'll continue with the review. You know, on the same token, what I would say is, you know, between now and Monday, go through the first 15 on your own. Make sure that you're coming up with the same answers. Make sure you can do them, right? And then, you know, if you want to try the next 15, try them. And then, you know, we'll still go through all of them, but I want to make sure you guys feel good about this stuff, okay? So anyway, that's it for us today, guys. Guys, the other thing is, if you have not yet had a chance to do the evaluation, if you could do it, that would be really helpful. I'm going to send an announcement. I'll resend an announcement about the course evaluations. I'm going to resend it out today just because tomorrow is the last day to get them done, okay?
Why?
Why what?
Why would they not have that?
No. Tomorrow's the last day to do the evaluation.
Yeah, that's what I'm saying. Like, why is it not after?
Yeah.
Exactly. What if like for some reason you became a complete psychopath in the test? Nothing on the test was the same as the
Yeah.
like, you know, and then we already did a really nice evaluation.
Yeah. I guess let's see. I heard something here in the chat. Yeah, Steve, you're right. The test will be online. It'll be just like the way test 1 and test 2 were, Steve. So guys, yeah, the evaluation is there. And then just to give you a heads up, let me show you how you can get to it. Let me hit student preview. So in case you haven't done the evaluation yet, y'all, The way you get to the evaluation is scroll down to the bottom, and there is a link right here. So, but the evaluation is there. So whenever you get a chance, guys, they send us like little emails just to give you a heads up. So I got one. I'm sure everybody gets the same email. I guess I got it Monday, and it just says like, so like for our class here, 4 people have done it, right? It says 4 people have done it. So again, if you get a chance, it closes tomorrow. What time tomorrow? I don't know. Does it close at midnight? I don't know. Like, I would assume it would be midnight. I would not assume for them like pick some random time like, oh, 4 o'clock is closed. Like I thought you said it closed today. Well, it did. It just closed at 4 o'clock. I don't know. Sometimes they do stuff that's kind of a little silly, but if you get a chance, guys, I would appreciate it. Okay. Again, that's what helps me figure out how to make things better from semester to semester. Like I know in the fall I'm teaching this class again, and I already know certain changes I'm going to make. Like, and I don't know if you guys notice or remember this or not, but I'm going to pull up my notes for our class here, 24-13. Okay, so like, let me see if I can go to, I don't know, maybe 2.5. I want to say at this point, okay, so I'm looking at my notes from chapter 2, and my notes in chapter 2, like I pulled a lot of the stuff from the book, but then when we got to, let me see, maybe chapter 3, let me see if that's where I kind of started doing it. Oh man, even some of this might still be, like a lot of this is stuff from the book. But then as you notice, as we kind of went on, you guys, I started pulling more problems directly from the homework. You know what I mean? So like as I got to, I'm trying to see if I can, I'll go to like 3, maybe by then. Even this is seems like a lot of textbook stuff. So a lot of textbook stuff here. But man, when did I start doing that? I know it was in chapter 3, 3.5 maybe. Okay, so here we go. It wasn't until 3.5 that I started taking problems more that came directly from the book. You know what I mean? From the homework. You know what I mean? So like I know that when I teach the class in the fall, I'm going to revamp my notes for chapters 2 and 3. I'm going to make them more direct, like the way we were basically the way we kind of started doing it towards the end of 3 and 4 and 5 and all that kind of stuff. I'm that changed already. Like I already know I'm going to do that. And I haven't thought about what other changes I'm going to make, but I know that was one like off the top of my head. I'm like, okay, I got to fix that because I do want it to be more direct. So again, any kind of guys, things that you found that were helpful, let me know. That's what helps me become better from semester to semester. I think I told you guys that I taught my first class in January of 1997. So this past December or this past January marked 25 years, but I still try to find ways to make it better. You know what I mean? I try to find things that I can do that will make the experience better from semester to semester, because even after 25 years, I don't think like, okay, everything is perfect. You know what I mean? Like, don't change it, right? It's working. If there's things that I can do to make it better, I want to do that. And even last night in my college algebra class, we did these problems where we were doing matrices. And let me see if I can pull it up because we did this last night. Again, you guys know I'm not organized, so I have to kind of think through my notes. But I think this might have been it right here, actually. Yeah. So before, when I would teach this stuff here, I would always show the students how to do this stuff, and we did everything by hand. And these matrices, to find determinants of matrices by hand, by 3 by 3, it's a pain in the butt. So what did we do last night? Like, hey, let's use our calculator. Why? Because the calculator will do it. We're going to get the same answer, and it's going to save you some time, right? So we went through all this stuff last night, but we did it using our calculator, right? So instead of me doing this stuff by hand, and some of them I did by hand because it's easy. It's easier to do it that way. When I do the 3 by 3 by hand, it's just a lengthy process. So anyway, I always try to find ways to, improve from semester to semester. So again, if you get a chance, guys, I really would appreciate it. Tell me things you like. Tell me things you didn't like. Whatever's good. Okay. So let me go ahead and